Part 2 of 7C.2 is this. We are going to be playing around with this b value. And so just like we looked at the cosine of 2x, we have a b value of 2. What that's going to do is that's going to allow me to fit 2 periods into 2 pi radians. The definition of b is not how many periods, the definition of b is not how big the period is. It's how many periods fit into 2 pi radians. The formula that I'm going to expect that you memorize is right here. This formula is going to work for sine, for cosine, for secant, and even for cosecant. That's what's nice about it. If you're trying to figure out how big your period is going to be with, let's say, the cosine of 2x, you can figure out what this period is going to be by using this formula. I'll show you an example in just a moment. We're going to have to graph, and so literally the only other 2 things that I have for you now you can do with me in your worksheet if you would like. We're going to be doing numbers 10 and numbers 14. If you would like to get your packet out and do number 10 with me, I'm going to walk you through how to graph something when you do not have a table. Because I'm expecting you to be able to graph all of these without a table. Here's number 10. The first thing I would like you to do is use your amplitude, the up and down, and label your y-axis. Do you know what your amplitude is on number 10?
2.
Perfect. I'm going to use 2 and negative 2. If you do not have marks on your graph, which I don't think that you do, you're going to label 1 mark, 2 mark up, 1 mark, 2 marks down, and you're going to put down 2 and negative 2 on your y-axis. The next thing you're going to do, step 2, label the 4th quartile of the period using the formula above. If you remember the formula, you write P for period is equal to 2 pi divided by b. And what was b? What's b in this particular problem? It's whatever is multiplying the x. It might even be a fraction sometimes. 2 pi divided by pi. Our b value is this one. Our a value is this one. In case you didn't know. So what does that make our period? How large is our period on this particular problem? What that means is that our period is 2 radians. That is our 4th quartile. 1 mark, 2 marks, 3 marks. The 4th mark, you're going to write down a 2 right below that 4th mark. If you don't have 4 marks, make 4 equal marks going from left to right. Now for right now, that's 2 radians, so that's about 114 degrees roughly, right? 57 degrees for every radian roughly, something like that. I want you to always label your 4th quartile, and I always want you to label your 2nd quartile. If this is 2 radians, then halfway would be how many radians? You always figure out what half of it is. If it doesn't go in evenly, just rise over 2. Something 3 over 2 or whatever it may be. You could figure out this one if you want to. You could figure out this one if you want to. Do you have to? No. It is up to you. So I have 1 over 2, 1, 3 over 2, and 2. That should all kind of make sense to you. And then I'm going to use the green mnemonic device to put critical points on quartiles. This is a cosine graph. I go up to my extrema. And every quartile, I say that mnemonic that we worked on earlier. Let's see if you remember what it is. So I want you to say what this is and say it out loud real quick. It goes, what? Then? Then what? Then what? Then what? And then what you do is you don't, even though this makes the shape of a V, you are going to smooth out the top and smooth out the bottom. Smooth out the top and smooth out the bottom. You're making these curves because remember, it's going to be coming back down. It needs to level out when it gets to the extremas. You will pay attention to the directions. If the directions tell you graph for 2 periods, you're going to graph 2 of these. If your directions tell you to graph for 1 period, you only graph 1 of them. If your directions don't say, here it doesn't tell you how long to graph it for, then 1 period is just fine. Simple. Now let's do something that's harder. Number 14. First thing I would do, just like it says in your notes for graphing, is I would label my y-axis based off my amplitude. If you know what the amplitude is, tell the person you're sitting next to for number 14. I hope you all said 2. The A value is -2, but the amplitude is the absolute value because it's a distance. So we label our y-axis first based off of the A value. The B value is whatever is happening to the x. So right now I have a pi over 4. I'm going to figure out what my period is based off of that B value. If the period is equal to 2 pi divided by pi over 4. 2 pi divided by B. Now some of you will do this math incorrectly, but let me tell you something. I've been teaching, like I told you, I've been teaching AMA for 7 years. And with a bunch of juniors, they're not as smart as a bunch of freshmen and sophomores, okay? The juniors, when they do this, they make simple mistakes. You will learn how to do this, and I hopefully learn how to do this correctly. So let me show you. 2 pi divided by pi over 4 is the same thing as 2 pi divided by pi over 4, which means if you're solving this, you can simply multiply by the reciprocal. That's the easiest way to do it. And you can figure out that your period is 8 radians. Now where I see these juniors going wrong, let me just show you the incorrect way. Whatever you do, don't do this. Because some people think, oh, that makes it 2 over 4, which is 1/2, and it's not. It's actually 2 over 1/4. 2 divided by 1/4 is 8. So if you do this, make sure you know there's an invisible 1 there. This 4, because it's on that third layer, is going to multiply that to get to 8. Keep that in mind. Now that we know that, that's our 4th quartile. It's 8 radians. So I count over 1, 2, 3, 4, and I put an 8 right below that 4th quartile. If I want to, I can cut it in half. I need to cut it in half. I need the 2nd quartile always labeled. I can choose to label the 1st quartile. Half of that is 2. And I can label the 3rd quartile by going, there's 3 of these, 2, 4, and then I go 6, then 8. It's pretty simple stuff. I'm graphing a sine wave, but this is a negative a value. Do you remember what that negative a value does to the graph? What happens to the first extrema? It's negative. So instead of going up first, it's negative. It's going down first into the valley. Negative. People frown. Okay, so let's do it. What was the first one? Is it midline or is it extrema? Midline. Then negative extrema. Then where? Then where? And then we're going to make this smooth curve. No pointy edges. This is a negative sine graph because it went down first, then up. And that's where I'm going to end your notes today.